Hey, this is Jim Bergman with MeasureQuick. Wanted to take a few minutes today and just show you some of the new improvements we made to the MeasureQuick platform. And then we also integrated in the SupcoRedfish iDVM550 and how that meter can really accelerate the testing process. It's really quite a cool thing here. So what I've got set up here, I've just got a training unit set up, and I realize this is going to be a little bit faster than you do it on a residential job just because we're not going inside and outside. But bear with me and you'll see how quickly you can actually get the testing done. So I'm going to go ahead and I'm going to start the unit up first of all because all these units have a little bit of a time delay in them. That time delay is going to take a minute to satisfy. The unit's got to run and settle out, and this allows me to get a few seconds to start putting on my probes. So I'm going to go ahead and do that. Take the cover off here. We'll just set that aside for just a minute. And then I've got the Fieldpiece probes set up here. I've done a couple things a little bit differently. So I can take out this Testo 510 real quick. I'll just put it up in the ductwork while I've got it here. So I'm going to measure static pressure for the 510. And we'll just roll the cord around here. And I've got a hole drilled in my return here so I can measure return air. And it's on this side of the filter. The filter's right here. So I can measure static pressure on that side of the filter and face the tips towards the airflow on there. So now I'm going to go ahead and go into MeasureQuick, turn that on, and we'll get the rest of the probes pulled out here and stuck on the equipment. So I've got on the probes, what I did here is I took and marked every one of them. So you can see this is marked for supply air. And obviously these two have serial numbers here on the bottom that you can see. I can just never remember what serial number's what, so I just marked my probes so I could identify them easily. So we'll go ahead and put the supply air up in the system up here. So that's up and running. And I've got two more here. I've got this marked outdoor air, and I've got the other one marked return air. So we'll go ahead and set this in the outdoor air. Air going into the condenser, right out of line of sight of the sun, and then return air. I'll go over here and just clamp it in, and that's my return air going inside the unit. So now I've got my temperature probes here, and again I've got them all marked: discharge line, suction line, and liquid line. So we'll go ahead and turn these guys on, and we'll get them put to the correct lines. So discharge line, I always almost measure. It is optional here. And one thing to notice on these probes, on the Fieldpiece probes, the connection here is the thermocouple. So if you don't have clean copper, you got to make sure it's clean, otherwise you're not going to get a good connection and this will flash yellow. So if I open this up right now, you'll see it turns yellow because it's not a good connection. This is the same thing you're going to see if you have dirty piping on there. So this one's my suction line, so I'll go ahead and clamp that there, and then liquid line, and we'll clamp it on there. So these will all give you an auditory and a green light when they're hooked up right. Now here I've got my high and my low pressure, so we'll turn those on. Tie this one to the true suction line. This is a heat pump here. So onto the true suction. So this is right off the suction line of the compressor. This is what we call in a heat pump the vapor line. Two different lines on there. Even though in air conditioning it's the same one, you should always get in the habit of using the one off the reversing valve for any application because that is your true suction. And then I'll go over here on the liquid line. We'll go ahead and get that hooked up. And we're just waiting for this time delay to end. So now I got all my probes hooked up. Condensing unit just started. So I'll set this bag down here. We'll go ahead and go into the toolbox for a minute. And I'm going to turn on my job length probes and get those going. And Testo Smart probes. I can go into my toolbox here. You can see all those are reporting in and are all mapped. Once you map them once, they'll hold the mappings forever, so you don't have to remap anything. And then I've got my Testo manometer here set up for total external static pressure, so that's all done. And then I'm going to go ahead and turn on my meter here. I'm going to set this up to kilowatts. So this Supco meter is actually a tri-display, so it's going to show us the wattage, the voltage, and the amperage all in one swoop, including power factor. So this really cuts down time on electrical here. We'll go ahead and connect that meter. You can see it's connected and it's showing us 0 watts. Now all the tools are connected and everything's ready to go on there. We'll hit the home button and we're more or less ready to start here. So in MeasureQuick right away, you'll see this cautionary triangle, and that's telling us that the system is not stable. So while we're putting in data, we're going to let the system stabilize. Everything in MeasureQuick is project-based. So I'm going to go ahead and start a project, AC tune-up, hit continue. Project notes is just where you want to put any notes. Now I'm working off a keypad here just to make it easier, and I'll put on my glasses so I can see what I'm doing. So project notes, job site information, This is going to pull up the physical location. This is the building we're in right here, so I'm going to drag and drop it on the building. Customer information now, the gym. Phone number. Billing and address is the same, so that's all pulled in. Hit submit, that's good to go. Now, equipment's a little bit different. Again, you're going to want to move this to the location. Sometimes you're tied to building Wi-Fi. It may not hit the location exactly, and this is probably the case in here. So I got to zoom out just a little bit. We're actually down here up Hillcrest Road a little bit. And this is not a function of the app. This is just simply because the tablet did not find the Wi-Fi properly. So I moved it over to the building. Now I'm going to zoom in a little bit and I can mark the exact location of the unit that I'm working on. So I'm working on this unit on the front here. I'll drag and drop that pin over until I get that onto the unit I want to mark. So that's good. System information, this is a split system. We're going to put a ream or just a rood. It's one of the two here. I think it's a ream unit. Model number here is a RANL-018-JAZ. When we get to the serial number here, what I can do is pull up the unit, and there's actually barcodes, 2 of them here on there, on the unit. So if I can get my iPad loose here, what I'm going to do is hit the barcode scanning, and we'll just move this over top of the barcode, and you'll see it'll scan it, and it pulled in that number right there, W261043376, which is the same as the serial number right here. So that definitely makes it a lot faster to put in those numbers. Air handler here, we'll do the same thing. So I'm going to again start the ream unit. The model number on this I'm going to have to put NA because I don't have the panel for it, but I do have the serial number inside here. So we'll go ahead, again, we'll grab this with the barcode scanner. And here, we can grab that in there, and boom, that number's in, and that's, again, tied in the barcode scanner up there. So it makes it really, really quick and easy to get those numbers into the application. And then down here, the coil is part of the air handler. So we'll just tab through those, and they're going to put NA and NA. And go ahead and submit. So now all that data is in. If you want to take a photo of any of these things, like if I want a photo of a label here, I can always hit take photo, hold it up against the label, and then take a photo of that and use that photo so I have that later for documentation if I need it. So it makes it really quick and easy to do that. Scroll down to the bottom, hit submit. Next thing is just information about the installation. So in this case here, the line set length is about 10 foot. The line set location, we'll just say is in a basement. Line set lift is effectively 0 in this case. Liquid line diameter, 3/8 by 3/4. Just tap to set the date on the filter, and then we can put in the filter height as a 40% pleated, and then it's a 14 by 20 by 1. So all that data is in here. We'll hit submit. System profile. Now this is an important step here. We want to make sure that we get it profiled correctly. This is a 1.5 ton system. 400 CFM per ton, 13 to 16 SEER TXV, high efficiency evaporator. The evaporator coil on these reams is a little bit larger. It's actually an 018 condenser and an 024 2-ton coil, so that effectively makes it a high efficiency coil on there. We also need to change our target subcooling on this, and I've determined that to be about 22 degrees on that, so we'll hit submit, and then we'll put also our total external static pressure in, 0.5 inches, and hit submit, and now that's good to go. Electrical information, condensing unit, single phase, nominal voltage 208, single phase, again 208, and evaporator fan type is a PSC. We'll hit submit, and now we'll hit submit again, and now the only thing we got left to do is our measurements. So now you can either view them here by tapping view and capture, or you can simply hit the view and measure quick, which is the way I prefer to do it. Doing it in MeasureQuick just allows me to see things a little faster. Right away I can see I have a fault here. We'll take a look and see what that is. So it's faulting the condenser may be dirty. Now realize we got part of this condenser blocked up against this evaporator, and part of this condenser blocked against the back wall here. So this doesn't really surprise me. It's also changing. These are all dynamic here. So you can see right now it just lost stability again, and we want to make sure it's stable before we perform all the testing on it. So while that's running, I'm going to go ahead. I got my 550 here. I'm going to go into the electrical section, tap on electrical. It automatically detects the meters connected to it. So now all I got to do is measure the amperage and voltage of the air handler. Now in this case here, I pulled the lead out, a hole here we drilled to the front. You can also just knock a knockout out of the side and extend it out and pull it out. Or we have a voltage splitter you can use if it's 110 volts on here. Or additionally, the meter's wireless. You can actually close it inside the air handler and get a reading here. So I have this set up on kilowatts. So I need to measure voltage and power at the same time. So I'm going to go in here, and whenever you can make electrical measurements, if you can use one hand, that's always the safest way to do it. And I'm going to wait here for just a second here, and it should come into my display unless I push the hold button here, which I bumped the hold. There, it's off hold now. So now we're at 231 watts, 209 volts, 1.1 amps, and a power factor 0.99. This is the evaporator fan. So I'll hit capture on that. So now that electrical reading's in. So now you notice I gather all that reading in basically one measurement. So we'll go over here to the condensing unit. So again, this would make you go outside at this point. I'm going to clamp around the hot leg on the power coming in. In this case here, I'm going to just use these alligator clips that come with a meter. And we'll screw those on there just so we can get a voltage measurement and not have to hold on to it. Now the cool thing is you can stream the data in off the meter real time. So as you're charging or something, you can actually watch real-time EER going up and down. It allows you to just really get a lot of information off the meter. Go ahead and clip this on the hot leg coming in, the red one. And we'll clip this one on the black one. And again, whenever you're working with power, one hand so you don't run it through your chest on there. And then if we come back over here, you can see now the condenser's pulling about 1,000 watts, 209 volts, 5.3 amps, power factor 1. We'll hit capture on there, we'll hit submit. So now you can see if I look at my performance, let's add this again here, I have my EER, my approximate SEER, my total external static pressure, my fan efficacy, all that stuff's in the good range there. This is my current weather data. Go back to information, that's the basics of the system. Outdoor readings, suction line, superheat, subcooling, liquid line temperature, everything looks like it's pretty well in range. The return air temperature is on the low side along with the return air dry bulb. So again, we have a low load on the coil here. And then back to our electrical readings, our BTU output, that sort of thing. Doesn't surprise me we have a low output on here because we have a restricted condenser, and also we have a low load in here, so it's like running right on the threshold there, and you can see all this stuff in real time. Again, we can see the condenser might be dirty is most likely the fault, which agrees with what we have on the unit in here. So we'll go ahead and we want to save this data. We hit save a snapshot. We can view that snapshot then. We'll just hit share and PDF, and boom, we got all the readings. So now you can see all the readings that came off the job length probes. All these are calculated values. There's a little calculator here. All the readings that came off the electrical meter. Our indoor measurements, same thing. Here's our Testo manometer that was reading our static pressure, and then our system information, geolocation of the unit we're working on, and all the performance data. So you can see real quickly how all this was done in really short order, and literally in the time it took the unit to stabilize, I got all the measurements pulled in, and I can be in and out on the job in less than half an hour, verifying that this piece of equipment is operating properly. Hopefully this gives you a really good idea of what you can do with MeasureQuick, and hopefully you see a lot more of you guys on the platform using it in your day-to-day jobs. This is Jim Burton with MeasureQuick. Thanks a lot for watching.